Any questions?
How about the quiz?
I'm expecting a question about anything in the course. Technically, that was a question. Any other questions? When someone comes up, and I have one question, is it okay if I ask a question? I was thinking, how much of a smart ass is it when I say, okay, you can ask another one if you wish.
You said you were gonna post the lab for tomorrow, but I checked and it's not there.
Okay. 2 o'clock. If I don't have it posted by 2 o'clock, then I will bring it with me. So there'll be nothing to print out. Test is next week, not tomorrow. All right, other questions?
Will we have a homework quiz on chapters 4 and 5?
No, I opted not to do that this time. Did you want one?
No, I.
I feel like we rushed through an example yesterday, or 2 days ago. So let's run through another one, add a little bit of information to it. If two objects collide and stick together, this is known as a perfectly inelastic collision. And just to make matters more confusing, some textbooks and some sources will call it just an inelastic collision and not perfectly inelastic. But if I make a reference to a perfectly inelastic collision, sometimes I just abbreviate that as PIC. I have two objects that are going to stick together. So this, a perfectly inelastic collision, now it would be nice that if you're looking at a problem and you see that there's a collision, you should immediately think conservation of momentum, especially since that's the chapter we're in. So let's start out with, what is the momentum of the 3 kilogram mass? Actually, before anyone answers that, out loud, I would like everybody to have a chance to actually come up with an answer, whether you localize it or not. Just give everyone a chance to come up with the answer for the momentum of this 3 kilogram mass. I'll give some of you a chance to look at your notes from Tuesday. All right, this is going to be really cool. It'll bring tears to my eyes.
Mass times velocity.
In unison. Great if we pull this off. In unison. What is the momentum of the 3 kilogram mass?
12 kilograms per meter squared.
Well, units were messed up. But it did not sound like everyone said 12 in unison. That was next time. What is the formula for momentum?
Mass times velocity. Mass times velocity.
Yes, it is a vector, so it is velocity, so mass times velocity. What is the mass of the 3 kilogram object? This is the kind of thing that I put a little gift icon next to it.
3 kilograms.
How do I know that this is a mass?
Because it has the unit of measurement.
Louder, please.
Because it has a unit of measurement.
Because it has a unit of measurement? Be more specific. I suspect that what you're thinking is correct, but the way you worded it was a little odd.
What's the thing by the P?
That subscript here,
Yeah,
that's a little 3,
okay.
just to differentiate the two. Matter of fact, I probably should put a little I next to it also, because this is the initial momentum.
Is it the scalar unit?
Because it's what?
Scalar unit?
Not the, it is a scalar unit, but let's narrow it down. And again, I'm trying to figure out whether you just said it wrong or whether there's a disconnect there. How do I know that 3 kilograms is the mass?
Because it's kilogram?
Yes.
Yes.
I don't know if that's what you intended, but units of kilograms are units of mass. So 3 kilograms. And the velocity?
4.
All right, when Robert said 4 meters per second, what did he do that's going to affect the rest of the problem?
Change the units.
Pardon?
Do you change the units?
No.
Is that the actual alignment? Never mind.
I heard that. As a hint, what he did because he was mighty. All of you could have done it. Because you were mighty. Oh, are you gonna make Robert spill the beans? Robert, what'd you do?
I determined right is positive.
Yes. As soon as he said the velocity is 4 meters per second, implied positive, he is establishing that way is positive. So the math problem is just 3 times 4. And now the units. And I suspect you would have written them down correctly, but you misspoke.
Say it right.
So what are the units?
Kilograms, kilograms times mass over 1
M is not the mass there.
4 meters per second.
Yeah, kilogram meters per second. I heard you say square in there. So
No, I said kilogram per, like, yeah, I added an extra word.
Okay. All right, so 12 kilogram meters per second. Or Newton seconds, or make up your own unit that's not being used already. We're cruising now. Everybody's gonna get the next one. What is the initial momentum of the 5 kilogram mass? And give everybody a chance to come up with the answer. I would hope there's gonna be 1 of 2 answers, at least numeric answers. Hopefully there's 1 correct answer, but I think there's a common mistake. All right, in unison, another chance. This is gonna blow me away. What is the initial momentum of the 5 kilogram mass?
Negative 30 kilogram meters per second.
That was actually very nice.
We did good.
Not perfect, so we have some room to grow, but still, I like it. Negative 30 kilogram meters per second. The most common mistake is assuming that you know the formula is to make it positive, but Robert ruined that by making it to the right positive. Okay, so we now have the 2 initial momentum. So what is the total momentum before the collision. And if you're not sure, it is easier than you might be thinking. Gabby, was that a
42?
one small issue?
Yeah.
I see where you get that from, but the 30 is negative.
Negative 18.
Yes. Let's get the whole thing.
Newton's seconds.
Okay, that works. Could I have used units of Descartes?
Yeah. Did yesterday.
What did I do differently yesterday that?
You declared it.
Yeah, I have not declared, I have not defined it yet, so I could use it, but I have to do something else first. Okay, so I know my total momentum before the collision, because momentum is conserved in a collision, and I'll get into a qualifier in just a moment. What is the final total momentum of the system?
Zero?
Sorry?
Zero?
Oh, no, not that. It is gonna be a simple answer, it's not that simple. Hint, conservation of momentum. Momentum is conserved in this collision.
-2.
Oh, no. How did you get that?
I took the 6 minus the 4 in the direction that they were going into.
All right, here's a hint. Oh, you got an answer? Conservation laws in physics means that whatever I have beforehand, I have afterwards. Therefore, what is my total momentum after the collision?
Negative 18 Newton seconds.
Yes. I've asked that on many tests over the years and always shocked at the hoops that people jump through when they find the initial momentum, total momentum correctly, and then I ask what's the final total momentum, and it's the number you just wrote down. This is the final. And I do not know why P is used for momentum. I heard it once, but it did not stick into the long-term memory. There are a number of videos I watched where people go, why? It seems to be a mystery, but I think it's from some Latin word, but I just don't remember. All right, so I now know the total momentum after the collision. I know that they are going to stick together because I said it was a perfectly inelastic collision. So I have these two masses, they are now stuck, they are now one. What is the mass of that one object?
Eight kilograms.
Yes. You knew that? That's also heads nodding, so
You knew it.
you could have said, could have beaten him to it. They are deferring to you. Apparently you are the class spokesman right now.
I'll stop.
So because I know momentum is mass times velocity, I have a single object after the collision because they stick together. So I have an 8 kilogram blob traveling in some direction. Now I know it's going to be traveling to the left, but if I could, just draw an arrow like that, indicating that it is going to move. And really want a marker that not much. So I have negative 18 Newton seconds is equal to my final mass times my final velocity. So again, it's just mass times velocity. I know my final mass is 8 kilograms. So I have negative 18 is equal to 8 times my final velocity. For those who don't like the subscript, my math problem is negative 18 is equal to 8x. That's the problem. That's the math problem. How would you solve for x? Okay. And so my final velocity, negative 2.25 units.
Meters per second.
Yes. We're finding a velocity, meters per second. So when we started out nicely, we end nicely. The negative means that it is traveling to the left. But we sort of could have figured that out already because, well, momentum was negative and momentum is in the direction of the velocity. Questions to hear? Yes?
Where did you get the newtons times seconds again?
So when you do mass times velocity, we get units, so the units of momentum would be the units of mass times the units of velocity. So that would be a kilogram meter per second. So that's where that comes from. We also have, there are two ways of getting to the actual answer to your question. I also know that the impulse, force times time, is equal to the change in momentum. The units, again, have to match. The units of this, the kilogram meter per second, would have to equal the units of force times units of time, which is Newton second. So these are equal to each other. Taking it one step further, just fun with units. If I divide both sides by the seconds, I have a Newton is a kilogram meter per second squared, which is the units of mass times acceleration. I know, deep inside all of you are going, other questions?
How did you get the initial momentum again?
The initial momentum, once I find the individual ones, are you good with how I got the 12 and the negative 30? Just add them.
Oh,
Yeah, there's nothing fancy there. All right, so now the qualifier to which I hinted earlier. That's something I can drop. Here we go. All right. I have a 20-gram mass, 20-ish. What is its momentum right now? Why?
It's not moving.
Right, okay. Doesn't matter what the mass is. Mass is 20 grams, assuming that it's probably close enough. Velocity is 0, momentum is 0. I let go of it. It starts to fall. Did the momentum stay at 0? I'm hearing some noises. I don't think it's the air conditioning. Why not?
Because it's moving.
Sorry.
Because it's moving.
Yeah. It went from not moving to moving, so the momentum increased. So if the momentum increases as it falls, is momentum conserved? So the question becomes, under what situations do we have momentum conserved and what situations do we not? So one of the things is, why did it fall when I let go?
Acceleration due to gravity.
Or more generally, the force due to gravity was causing it. What caused that force due to gravity?
The earth.
Yeah. I have two objects. I have this 20-gram mass, and I've got the Earth. And when I let go, I started out with zero momentum. I let go, the mass is falling. In order for momentum to be conserved, what does the Earth do?
Push back with the same force.
Think in terms of momentum.
The impulse?
Sorry, say it
The
again.
impulse of momentum?
Sorry, I still missed a word there.
The impulse of momentum?
Oh, not time to bring in impulse. But let's think about the Earth. Let's figure out what it did. Using this idea of conservation of momentum. So I have a 20-gram mass, 20 grams or 0.02 kilograms. Let's assume, let's just simplify it, acceleration due to gravity on Earth, close enough to 10, we're gonna use that. And so the Earth pulls down on this with a weight of about 0.2 newtons. By Newton's third law, the Earth is being pulled up with a force of 0.2 newtons. As it falls, it starts getting faster. So let's say at some point it is traveling down at 5 meters per second. So that would be at some point this thing is falling, so that's the velocity of the 20-gram mass. Just put a little 2 down there to represent the 20. I guess that's the speed of the 20-gram mass. So I know my total momentum has got to be 0. Because I had the Earth there, I had the mass here, they were sitting there. It starts moving, so when it's going 5 meters per second, so my initial momentum is equal to my final momentum. That's 0. So at this point right here, when that 20-gram mass is going 5 meters per second, what is its momentum?